Okay, so I'm Gary. I'm from NanoString, scientist there, does assay development. We are not going to talk about next-gen sequencing sample prep, but we are going to talk about sample preparation for use in our system. So we've, for those of you that didn't see the talk at noon or earlier this morning that I gave, we have a digital detection system, a nucleic acid detection system, where we count individual molecules of nucleic acid. And I'm going to go over, I'm going to go over the core of the technology somewhat briefly so that you get an idea of what we do and why the sample prep issues or concerns that I'm going to talk about, what the basis behind them are, and then talk about general consideration, assay considerations from a sample prep perspective for the entire assay. So based on the kind of the novel way that we detect RNAs or DNAs, and then I'm going to go through assay-specific considerations. So I'm actually not going to talk about microRNA. So if you want, I was short on time here. But I am going to talk a lot about mRNA because that was our first application. We have a lot of data surrounding different sample types and sample considerations. And then since this is a copy number session that most of us are attending, I'll talk a little bit about our copy number assay, which I talked about in detail this afternoon. So again, I showed this afternoon, this is basically, we believe our technology is very well suited for this kind of validation and routine testing of samples that have been discovered by next-gen sequencing or microarray technology or whatever your favorite discovery tool is. So, obviously these, well, at least for now, these technologies are give you very large amounts of data over whole genomes or whole transcriptomes, but they are somewhat difficult to automate, as we just heard, and do in a high throughput and very simplified manner. So the sample preps are complicated. It takes skilled technicians to do these assays and so forth. So our assay it's very simple to use. It's pretty much all of it is automated other than the hybridization step, and we cannot look at the whole transcriptome. We are looking at the tens of genes to the 1,000 gene level. So tens to many hundreds of genes across hundreds or potentially thousands or tens of thousands of samples. And what is the basis behind this system is, as I mentioned, a digital detection nucleic acid system. It uses color-coded molecular barcodes, which I'll talk about in a second. Up to 800 targets in a single tube, so we're multiplexing in a single tube up to 800 targets using these barcodes. One of the keys here is that we are doing direct detection of the sample, so we're not amplifying the sample. We're not cloning the sample. We're not putting ends on the sample or anything like that. We're measuring it directly out of the extract. Digital readout, we're counting molecules, so it's digital. And that allows very sensitive, reproducible data and a very simplified workflow.